In 1945, inside a top-secret nuclear reactor at Oak Ridge, Tennessee, scientists weren't just building an atomic bomb. They were sifting through its atomic ashes. And in that radioactive fire, they found something that had eluded science for decades. This was the moment Element 61 was finally captured, a cursed phantom that had haunted the periodic table and defied every attempt at discovery. The story of Promethium isn't just about finding a missing piece, it's a tale of scientific triumph born from the most destructive force ever harnessed by humanity. Hello, and welcome to Meet the Elements, the series where I take a look at the stories of humanity through the lens of the periodic table. Promethium is an interesting element, not because it's all that useful, but rather because the story of its discovery is so fascinating. It was the last naturally occurring element to be discovered, and it was such a challenge that when it was finally discovered, being named after Prometheus seemed fitting. But we'll get to that. To understand why this discovery was so monumental, we have to go back a few decades. The gaps in the periodic table were mostly filled by the beginning of the 20th century, but it still had a single nagging blank space that taunted scientists. Right between neodymium and samarium, there was a void. This gap for element 61 meant our understanding of reality was incomplete, launching a decades-long hunt for a piece of the universe that didn't seem to exist on Earth. As early as 1902, when the periodic table was still arranged by atomic weight, a Czech chemist named Bohuslav Bronner had a strong suspicion. He looked at the periodic table and thought something wasn't quite right. The chemical relationship around neodymium and samarium felt incomplete. It was like listening to a musical scale with a missing note. Bronner predicted there had to be an undiscovered element sitting right there, and it wasn't too long before his prediction got some evidence to back it up. In 1914, the physicist Henry Moseley used X-ray spectroscopy to prove that an element's identity is defined by its atomic number, the number of protons in an atom's nucleus. Moseley's work confirmed Bronner's prediction. Element 61 was missing. The hunt was officially on. The periodic table was found incomplete. For scientists, it was an irresistible challenge. They knew what the missing element's properties should be, and they knew where to place it. All they had to do was find it. How hard could that be? As it turned out, it was actually incredibly difficult. The search for element 61 became a scientific ghost story, haunted by discoveries that weren't true. The 1920s in particular were a hotbed of claims and counterclaims. In 1926, two separate teams announced they had found it. An American group from the University of Illinois claimed to have isolated the element, proposing the name selenium, but almost at the same time, a rival claim emerged from a team of scientists in Florence, Italy, who proposed the name Florentium. But as other labs tried to replicate the results, the claims fell apart. The evidence was flimsy, the signals likely just artifacts or contaminants from neighboring elements, which are themselves difficult to separate. The scientific community grew skeptical, and the furor died down, leaving only embarrassment and frustration. Element 61 seemed to be actively resisting discovery. It was almost as if it was cursed. So why was this element so hard to find? Well, element 61 isn't just rare, it's fundamentally unstable and radioactive. There is not a single stable isotope of promethium. Its most long-lived form, promethium-145, has a half-life of 17.7 years. Any promethium that might have existed when the Earth was formed would have vanished long before we started trying to find it. Scientists were chasing a ghost because, in nature, that's practically all it was. It's estimated that at any given time, there's only about 500 to 600 grams of the element in the Earth's crust, mostly created from radioactive decay of heavier elements. Finding it was like trying to find a specific handful of sand across all the beaches in the world. The curse of element 61 was real, and it was written into the laws of physics. It turned out to find this elusive element, scientists needed a new kind of fire, and it would come from the most impactful project of the 20th century, the Manhattan Project. The quest for the atomic bomb pushed the boundaries of physics. At places like the labs in Oak Ridge, Tennessee, scientists were building nuclear reactors to control the power of nuclear fission. They were splitting uranium atoms, releasing immense energy and, as a byproduct, a cocktail of other highly radioactive atoms. These were the fission products, the ashes of nuclear fire. The scientists at Oak Ridge realized they had a unique opportunity. Inside the reactor, elements were being created that didn't exist in nature. If the impossible-to-find element 61 was ever going to be found, it would be here, freshly forged in the core of a nuclear reactor. The problem was, how could one sort through that chaotic jumble of radioactive isotopes to find it? The answer came from a brilliant new technique. The moment of discovery wasn't a shout of eureka through the lab. It was a painstaking, meticulous process of separation. The team at Oak Ridge used the groundbreaking method known as ion exchange chromatography. Think of it like an incredibly sophisticated filter. They would dissolve the radioactive waste and pour it through a column filled with a special resin. Different elements in the mixture would stick to this resin with varying strengths. By washing the column, they could coax the elements to detach one by one. It was slow and methodical. They collected the fractions of washings from the column, testing each one for its radioactive signature. And there, in the fractions between neodymium and samarium, a new signal appeared, a radioactive signature that didn't match anything seen before. After decades of searching, Jacob Marinsky, Lawrence Glendenin, and Charles Coriel had finally done it. They had captured the ghost. The element that was too unstable to exist on Earth was finally found by sifting through the ashes of the atomic fire that was about to change the world. Due to wartime demands and secrecy, their discovery wasn't announced until 1947. But when it was, it closed the last gap in the periodic table. Now that they had found it, they needed to give their discovery a name. After the false starts of selenium and fluorentium, this name needed to be perfect. The honor went to Grace Coriel, the wife of discoverer Charles Coriel. She was the one to suggest the name Promethium. The name came from the Greek titan, Prometheus, who stole fire from the gods on Mount Olympus and gave it to humanity. For this act of daring, he was punished by Zeus, chained to a rock where an eagle would eat his liver each day, only for it to grow back. The name was a potent symbol. It represented the daring of the human intellect in harnessing the power of the atom, stealing fire from the gods in a manner of speaking. But it was also a somber warning. It was meant to symbolize the daring and potential misuse of the human intellect. The discovery born from the atomic bomb was named as a caution against its own power. Despite its cursed origin and ominous name, Promethium's fire has been used for some remarkable purposes. The element's steady radioactive decay, which once made it impossible to find, is now its greatest asset. One of its most important uses has been in atomic batteries. These devices use the beta particles from Promethium-147 to create electricity. These tiny, relatively long-lasting power sources have been used in devices like pacemakers, providing a steady, reliable current for several years. In a way, this is the closest we've come to the dream of a tiny, walnut-sized nuclear generator. Its radiation has also been used in more down-to-earth applications. For a time, Promethium's radioactive glow was used in luminous paints for watch dials and signs, replacing the more dangerous radium. Even though it's one of the rarest elements, the gift of Promethium has found its way into our lives, proving that even a cursed element can become a blessing. The story of Promethium is more than simply finding one element. It's a story about the relentless nature of scientific curiosity. For decades, a blank spot on a chart was an intellectual itch that scientists simply had to scratch. They chased ghosts, followed false leads, and were told it was impossible. And then, in the heart of a nuclear reactor, they found it. They turned the very instability that made it a ghost into a source of power. They took a scientific curse and turned it into a triumph. The tale of Promethium reminds us that our map of the universe is always a work in progress, and sometimes the most incredible breakthroughs are found when we have the courage to chase the ghosts and tame the fires of the unknown. It shows that even the most fleeting parts of our universe have secrets to share, if we're just persistent enough to look. Thanks for watching. I'd like to thank viewer MomoPandas9242 for suggesting I cover some of the lanthanides. While I didn't really talk much about the lanthanides in this video, this is just the beginning, and there is much more to come. But I want to hear from you. What part of Promethium's story do you find the most interesting? Let me know down in the comments. And while you're there, leave a suggestion for the next element you want to see me cover. And if you want more stories about the elements that shape our world, make sure to subscribe so you don't miss the next episode of Meet the Elements.